Okay, let's go ahead and take a look at 11.3 homework, area of circles and sectors. So for number 9 and 12, it says find the area of each circle, and I know it says round to the nearest tenth, but I want you to leave your answer in terms of pi. So how do we figure out the area of a circle? Well, we're going to be using this formula, a equals pi r squared, where r is the radius. So use this formula, plug the information in, and then you should be able to find the area, and be sure to leave your answer in terms of pi. For 15 and 17, I'm just going to look at number 15 here. It says, find the indicated measure round to the nearest tenth. 15 says, find the diameter of a circle with an area of 94 square millimeters. So remember the formula, or the area formula for a circle is A equals pi r squared. And the fact that the area is already given, I can replace A with 94. So 94 is equal to pi r squared. The diameter is, twice the radius. So if I solve for the radius first, then multiply that by 2, that's going to get me the diameter. So in this case, I have 94 is equal to pi r squared. I'm going to divide both sides by pi. So 94 divided by pi, so that's what I have right now, 94 divided by pi, which is equal to r squared. Okay, so how do I get the radius by itself? I got to take the square root on both sides. So I'm going to input that square root of 94 divided by pi using my calculator here. And this is round to the nearest tenth, okay? So my r, my radius, is approximately 5.5. So the diameter is approximately 5.5 times 2, which is 11. So it's going to be 11 millimeters. Okay, so you should get 11 millimeters, or if you looked at the key, if you got, for your radius, so if I'm going to do the square root of 94 divided by pi, if you got 5.4700296, and you take that and you multiply that by 2, okay, you're going to get a different answer, but this is what appears on the key. It's 10.9. So 11 or 10.9 works for me. So r is approximately 10.9, or you can just give me 11 if you chose to round your radius first and then input it in, or if you find your radius first and then round that to find the diameter, that's totally fine. Or if you just took that 5.4700296, multiply that by 2, and got 10.94, and so on and so forth, and that's where you round, that's totally fine, okay? And then 17 will be an exercise for you to do. Okay, so here, 18 to 23, find the area of each shaded sector. This one, I want you to leave your answer in terms of pi, so don't round to the nearest tenth. For 22, we're going to find the area of the shaded region. So this is what I'm looking at right now, the shaded region. Notice that this angle here is 55 degrees. So what's this? Well, all I have to do is 360 minus 55. So I have 360 minus 55. That's 305. So I do... Remember, the formula is A equals x over 360 times pi r squared, right? So it's A equals 305 over 360 times pi 11.2 squared. Okay, so then let's go ahead and figure out what 11.2 the quantity squared is real quickly. So 11.2 the quantity squared is A equals 305 over 360 times 125.44 pi. Okay, so now let's use our calculator. 305 divided by 360 times 125.44. Then this is where I'm going to press math, enter, enter. And, oh my goodness, you will get this number. Okay, so it's going to be that pi millimeter squared. Number 29, the area A of each shaded region is given. Find the value of x. Okay, so this looks like a sector area problem. So sector area is using this formula. A equals x over 360 times pi r squared. So A equals x over 360 times pi r squared. Note that the area is already given. So I'm going to replace A with 128, which is equal to, so I'm trying to figure out what x is. So that's essentially, what's x? Well, x is this, so from the center to the circle, that's our radius, okay? So, you know what's really, really confusing? That we have double x here. So let's just say that there's a difference between, let's just say that this x is in degrees and then this x is the length, okay? So there's x and x degrees. So A is equal to x degrees out of 360 degrees times pi r squared, okay? So the x degrees is 152 out of 360. And then you multiply that by pi x squared, because from the center to the circle is your radius, which we will call x, our unknown. And then this is what I'm going to do. I am going to essentially multiply, or I'm going to simplify this. I'm going to simplify this. So I have 128 is equal to 152 times pi times x squared. 152 pi x squared all over 360. And I'm going to get this by itself. So to do that, I got to multiply both sides of the equation by 360. And 360 times 128 is this number. 46,080 equals 152 pi x squared. Okay, so how do I get x squared by itself? I got to divide both sides. I got to divide both sides by 152 pi. And then I should get this part. Okay, so now I'm going to take the square root on both sides, and you should get x is approximately 9.8 feet. And there you have it. Number 31, the age of a living tree can be determined by multiplying the diameter of the tree by its growth factor. So I highlighted that part because you're going to need that to figure out what B is. And the growth factor can be also the rate of growth. The coast live oak is the largest tree in Texas. A, what is the diameter of a live oak tree with a circumference of 36 feet? Okay, so first of all, if you recall, to find the circumference, you use C equals 2 pi r or C equals pi d. Okay, I would use C equals pi d for this one. And And so for A, your circumference is already given, and you're being asked to find the diameter, so you're working backwards for this problem. And once you find once you have figured out the diameter, then you're going to answer B. If the growth factor of the live oak tree is 130, what is the age of the tree? Well, all you're going to be doing is just reading the word problem again to answer that question, and that's my hint. So let's look at 33. Find the area of the shaded region. The rule here is when you're trying to find the shaded region, it's basically the shaded minus the unshaded. Okay? The goal here is that you're finding the area of the shaded region, as you can see here. Okay? As we can see that you're dealing with two shapes here. You see a square and a circle, and this one is a circle and a triangle, and this one is dealing with two circles. I'm going to do number 33. Just by looking at this circle with this triangle inscribed, you can see that, okay, well, number one, my goal here is to find the shaded region, correct? You need to figure out the area of the circle, and you also need to find the area of the triangle. And once you have those two objects, you will do that rule. You will find the shaded region, and then you're going to minus that by the unshaded region, which is the triangle. As you can see, with this triangle, it's an isosceles triangle. It's actually an isosceles right triangle. Okay, if you remember, the vertex is on, and this is the diameter, we can safely assume that this is 90 degrees. And since this is an isosceles right triangle, if this is 5 root 2, then this segment is also 5 root 2. So I'm really applying 45, 45, 90. That's our special right we're going to be dealing with. So label across from 45 degrees. This is going to be A. Across from 45 degrees, this is also going to be A. And then lastly, across from 90 degrees, the diameter is not 2A, it's actually A root 2. Okay, so A is equal to 5 root 2, and the diameter is A root 2. So all I got to do is, okay, I know that A is 5 root 2, so I'm going to replace this A with the 5 root 2. So your diameter is what? 5 root 2 times root 2. So 5 times 2, because root 2 times root 2 is what? 2. D is equal to 10. The diameter is equal to 10. Okay? All right, so let's figure out the area of the circle. The area of the circle is equal to pi r squared. And, well, I know that I'm just going to have my pi there. But what's the radius? Well, the radius is half of the diameter. So r is equal to 5, right? So it's 5 squared. So your area is 25 pi. That was easy. Let's go ahead and figure out the area of the triangle. So area of the triangle. And the area of the triangle is 1/2 base times the height, where the base and the height, they are perpendicular to each other. So we can easily, spot that here, because this segment is perpendicular to this segment. So it's equal to 1/2 the base, it's 5 root 2. And it's multiplied by the height, which is also 5 root 2. So this is what I'm going to do. I'm going to ignore the 1/2 right now. 5 times 5 is 25. So I have 1/2 of 25. And then I have root 2 times root 2, which is just 2. So 25 times 2. So 1/2 of 50 and 1/2 of 50 is 25. Okay? So what do I do again? to figure out the shaded region, shaded minus unshaded. So you do 25 pi. So let's do this. The area of the shaded region is equal to 25 pi, 25 pi what, meters squared, minus 25 meters squared. So I'm going to put that all into my calculator. So 25 second caret sign to bring that pi button, then minus 25. And you should get, and I'm going to round to the nearest tenth here, you should get approximately 53.5 meters squared. That's the area of the shaded region. I'm going to check my key to see if I'm correct, because I didn't look at that at all. There you go, 53.5 meters squared. Yes, that's also, that's what the key has. Cool. And then you can go ahead and figure out 32 and 40 on your own.